Today we're going to talk about statistics and parameters. And before we look at a sample problem, let's go over about three definitions. One is statistical inference. And statistical inference is the statistics, sometimes that's a hard word to say, statistics of a sample that are used to draw conclusions about an entire population. So we got a statistical inference, we got a sample, we gather some statistics, and then we draw some conclusions that we would apply to the entire population. And then a statistic. A statistic is a measure that describes the characteristics of a sample. So statistics and sample go together, S and S. And then parameter are measures of a characteristic that describes a characteristic of a population. Population parameters, sample, statistics. Now in this example, we're asked to identify what the sample is, identify what the population is, and then describe the sample statistic and the population parameter. So let's begin. So here we got this problem. Starting with a randomly selected box of cereal from the manufacturing line, every 50th box is removed and weighed. The mode weight of a day's sample is calculated. Mode. Let me just address mode right quick. We have three measures of center, and they are called mean, median, and mode. Mean is just a simple average of the data collected. Median is the midpoint of the data if you have it listed from in either ascending or descending order. In other words, from the lowest to the highest, that would be ascending order. The midpoint of those data points would be the median. And the mode would be the measure that appears most often, and there can many times be even more than one mode, mean, median, mode. All right, but in this example, that's a little bit beyond the scope of what we were asked to do, because we're asked to identify the sample, the population, and then describe the sample statistic and the population parameter. So let's start with the sample. Well, we see here that we're going to randomly select a box of cereal coming off the line, and they are removed and weighed. So our sample are the boxes that are removed and weighed. And then what's our population? Well, our population then is all the boxes that are made in the factory. Okay, so we got a sample. Every 50th box is being pulled and weighed. It's random. Let's see, what about the sample statistic? Well, the sample statistic is going to be the mode weight of all the boxes. All right, and what about the population? And that's from the sample. Sample statistic, mode weight of all the weighed boxes from the sample. And what about the population parameter? Well, that'd be the mode weight of all the boxes. So, and again, you can see why we need to use samples. Depending on how many boxes of cereal are coming off this production line in this manufacturing plant, that could be, if you're trying to weigh every one of them, that could be quite a bit. If we're weighing every 50th box, we're getting some idea of what the mode weight, and they're trying to keep it within a certain range, which is measures of variance, which we'll be talking about a little bit later.